Hi team, welcome to Wiggins Maths. In this video we're going to look at integrating by using trigonometric identities. As always, do not neglect the formula booklet. So there are loads of trig identities, but if I was going to say learn just two, these would be them. Everything that you're going to need to know stems from these two. These are formulae you get given in the booklet. And it's worth making a note that sine A plus B, we can create the double angle identity sine 2A. So where you don't necessarily have to learn this by heart, you can get it from the formula book. Same with cos 2A. Can be written as cos squared A subtract sine squared A, which again, this can be written in many different ways by replacing cos squared A or sine squared A. Okay, so let's move on to tan squared x, the integral of tan squared x. I don't know how to do it. I have a quick glance in the formula booklet and it's not there, which means I need to use something else. Now I just said there's only two formulae that I want us to know, so let's write one of those down, see if that will help me at all. Oh, I can make tan squared x if I divide through by cos squared x, so let's do that. Okay, so tan squared x is therefore sec squared x take 1. Rewrite the question. Now, does that help? Yeah, sec squared x in the formula book. I can now write down the integral plus c, of course. So the integral of tan squared x is tan x subtract x plus c. Okay, sine 4x, cos 4x. Now, this will take a little bit of experience on your part, recognizing that sine A cos A can be written in the form sine 2A is 2 sine A cos A. Now in this case A is 4x, so therefore I can write that sine 8x is this, and now I can rewrite my integral as sine 8x over 2, which I know how to integrate. Sine becomes negative cosine, and I must divide through by that 8 plus c. Okay, so this is where I encourage you to not forget the things you already know. Here we have a double bracket which we can expand, so let's do that to begin with. Okay, once we get to this point, it's important to look at each individual term to see if we can work with it, if we can integrate it. So sec squared x, yes, in the formula book. Sec x tan x, yes, in the formula book. Tan squared x, well, we did that in example 1, so yes, we can. So sec squared x becomes tan x, 2 sec x tan x becomes 2 sec x, and tan squared x becomes tan x subtract x plus c, and then we can collect like terms. So 2 tan x add 2 sec x subtract x plus c. Lovely. Okay, so this one again, a little bit different once again. Let's deal with what I can do first. So again, expand that numerator. So we get 1 plus 2 cos x plus cos squared x. So that doesn't really help at the moment. Maybe there's another way I can rewrite it. Oh, I can take each term and divide it by sine squared and rewrite it in that way. Let's see if that helps. So still an integral. 1 over sine squared is cosec squared x. 2 cos x over sine squared x. It's a little bit more awkward, but that is 2 cot x cosec x. And cos squared over sine squared is cot squared x. Okay, so again, we need to look at each individual term to see if we can integrate it. Cosec squared x, yes. Cot x cosec x, yes, in the formula book. Cot squared x, nowhere to be seen. Okay, so we need to deal with this one here. So again, let's use that identity I've asked you to know. Cot, yes we can. 1 plus cot squared x equals cosec squared x. So cot squared x equals cosec squared x, take 1. That's quite nice. So now I can integrate 2 cosec squared x plus 2 cot x cosec x, subtract 1 with respect to x. Okay, now each term we can sort out. So 2 cosec squared x becomes negative 2 cot x, and 2 cot x cosec x becomes negative 2 cosec x, subtract x plus c. Whew, we did it. Okay, and finally we have a question like this, which is to do with our compound angle formulae, as I showed you earlier in the formula booklet. So we want to find sine 7x and sine 3x. So let's write these out as it suggests in the question, using that formula. Okay, so let's add those together, because that's what it asked me to do in the question, and I get sine 7x plus sine 3x equals, those two terms cancel out, lovely stuff. So I've shown exactly what we want. Okay, hence or otherwise. Now, this is why I'm brutally honest and remind you, it means hence. It just does. So now we're going to use our knowledge of what we've just done, and actually I can rewrite this as this integral now. Okay, which I can integrate. And you know what? That will do, won't it? There's no real benefit in multiplying through by a half. I suppose I could do, but I think that is what we want to get from here. Now, it's worth pointing out this skill takes a serious bit of practice. Okay, the key is understanding if you don't know how to integrate something directly, or it's not in the formula book, then there must be an identity to help. Okay, they're not going to give you a question that you can't access. Okay, so polite reminder that by watching this video doesn't instantly mean that you're going to get it or be able to do it, and the more you practice, the better you'll become, and that really is the key. And of course, amateurs call it genius, masters call it practice.